Teacher Jeffrey here. Welcome to our topic homeostasis. This time I would like to recognize the work of my students. Let's go and dive in now.
So, I guess this is going to be an educational video.
Done. I, Jun Li, also known as Sky Frostive, and I'm Darwisy, also known as Darwisy 1205, will be the narrators for this video. Well, Teacher Jeffrey needs us to do this
I wonder why. Asking a question that's not sarcastic.
project. And this project is about homeostasis. The topic is osmoregulation.
What's that?
Bruh.
Just tell me the definition of osmoregulation and homeostasis, please.
Basically, osmoregulation is the control of water and solute concentrations or levels, such as mineral salts, in the blood to maintain a constant water potential in the body. While Darwisy, how about you do the honors? I need to take a breath.
Okay, so homeostasis is the maintenance of a constant internal environment. In that case, osmoregulation and temperature regulation are the examples. Osmoregulation is involved with the water potential in the blood plasma. The water potential depends on the amount of water and solutes in the blood plasma. It could be concentrated or diluted according to our daily activities. But we're just going to be focusing on how and what if it gets concentrated.
So when we sweat while we're exercising or in a hot day, we lose water. Because, sweating. Loss of water in the body causes the blood plasma in our blood to become too concentrated, as in more solute in per volume of blood plasma. And this causes water in the cells, such as red blood cells and tissue cells, to move out of them into the blood plasma by osmosis, which will make the cells dehydrated and shrink, causing them to be unable to carry out their metabolic functions properly. In severe cases, this may be
Fatal to the organism.
which is obviously bad. Damn, what's the solution?
The solution is osmoregulation. Tada. So, this is how it goes. When we lose water such as sweating, our water potential in blood plasma decreases.
Water gone
forever and ever and ever and ever and ever.
Can you stop that?
Sorry, continue.
This will then stimulates the hypothalamus in the brain. Yes, this sounds complicated. Mus. Dumb pronunciation. The stimulus will be like,
Hey hypothalamus, there's less water in the blood plasma. You know what to do, right?
the hypothalamus in the brain then produces a hormone called ADH. This is going to sound a little complicated. Well, the full name is antidiuretic hormone. Anti means no or not, while diuretic means water loss. So, it's basically an anti-water loss hormone, just for an understanding here. It controls the amount of water in the blood plasma.
I'll take the next line.
Thanks.
ADH is then released by the pituitary gland and into the bloodstream. There is something that is need to be explained, too. It's the urinary system. It's something to do with the urine, or which is what some of you said, pee, and the kidneys. Obviously, everyone here knows what kidneys are.
Yes.
They're involved because they are called osmoregulators. And they sound alike.
So, most of you guessed its functions. Obviously, it creates and releases urine which contains nitrogenous waste such as urea, uric acid, and creatinine out of the body when it filters the blood. The nitrogenous waste is filtered out, and so is some small essential molecules and water molecules. And this is when selective reabsorption is carried out, which is when the essential molecules and water molecules get absorbed back into the bloodstream, but the reabsorption of water varies based on ADH and stuff.
Everything's coming together. Hear me out, do you remember what I said just now? I guess like in the middle of the video, there's a pop quiz. And if you answered incorrectly, you should
Restart your computer.
Just kidding. I think most of you thought about ADH, so yeah. So the thing is, the amount of ADH released by the pituitary gland depends on the water potential in blood plasma. If the water potential is low, more ADH is released into the bloodstream. And vice versa. In this case, more ADH is released. When the hormone in the bloodstream reaches the kidneys in the urinary system, it'll then causes the cells in the walls of the collecting ducts, which plays a role in selective reabsorption, become more permeable to water. More water is reabsorbed from the collecting duct into the bloodstream.
This way, smaller volume of urine is produced, and it's more concentrated, so it's more yellowish than usual. Thus, the body can conserve water while releasing the toxic waste through urine. And that, the water potential of blood returns normal. Bam. Just like magic. Probably not because it's biology and stuff. And that's it on about homeostasis, or more specifically, osmoregulation.
We hope you liked the video. We really hope so. Thanks for watching and good night.
Wait, don't use that word good night. What if there are others watching in the morning, at the afternoon, nor even the last day of humanity?
Fine, goodbye and good day, is that good?
Okay.
Bye.
See ya.
This ends our feature video presentation. They discuss about loss of water in the blood plasma, which is part of osmoregulation under the topic homeostasis. This is Teacher Jeffrey. A goal without a plan is just a wish.